Hey, what's going on, guys? Let's look at this problem right here. Here, this question is asking, determine which of the following signals are periodic and compute their fundamental period. Okay, here we have different signals provided to us. We have to find out whether it's periodic, and if it's periodic, what is the fundamental period. Okay, now let's look at the A part of this. In the A part, we have cos 0.015n. Okay, and here you can see this is a like sinusoidal, like sine wave and cosine waves, and we have something with a phi here. So to find whether it's a periodic or not, what you have to do is you have to take this phi part, leave this unknown, like you take this. Let me use a different color. I take this 0.01 phi, and instead of small n, I put a capital N, and if you calculate this, that's the period. And here I equate this one to a 2 phi k. And what I have to do here is I have to put any integer for k starting from 1 and see if I can get a whole number. If I get a whole number, it means the period exists. If I cannot get an integer, the period doesn't exist. Okay, that's all we have to know. And if I get a whole number, and that's the period. For example, if I put 1 here, what will happen? If I rearrange this one in terms of n is going to be 2 phi over k, and 0.015 phi cancels, and this one also equivalent to 1 over 100. Okay, instead of 0.01, you can also put 1 over 100 here. This 100 flips and go multiply on top, so 200. So 200k, you can simply put a 1 for k and make it to 200. So you put a 1 here. You can put any integer, but you have to start from the smallest one to bigger one, because we are trying to find the fundamental period. It means when the integer is the lowest integer, what's going to be the period. So here, if I put a 1 for this, the period is going to be 200. So this is the answer for this one. This is a periodic signal. At the same time, it has a fundamental period of 200. Okay, that is for the first one. And if I look at the second one like that, cos phi 30 n divided by 105. Same approach. What you do, you bring this part that is with a phi, you only take bring this n and put a capital N for it. So here this is phi 30, and instead of n I put a capital N and divided by 105, and that is equal to 2 phi k. Okay, now what you have to do is we can right away see phi cancels. Here we have a 30 and 105 right here, and 2 times 105, that will make this one 210k divided by 30. So this is like divisible, like 210 divided by 30 is nothing but 7. Okay, 7, so 7k, and you substitute k 1 for k and you get 7 here. Okay, you have to just substitute an integer whole number, and that if that gives a whole number for it, then this is the period, and the fundamental period is the 7. Okay, let's look at the C part of this. In the C part, we have cos 3 phi n. So I mentioned here, this is periodic, and the fundamental period is this 200, and this is also periodic. Fundamental period is 7. And here to see whether this is a periodic, I put 3 phi capital N. Let's use a different color. 3 phi capital N, and I equal this one to 2 phi k. Phi cancels. I get N, that is equal to 2 over 3k. if I substitute 1, that becomes an integer. We shouldn't have an integer for this, so I go for the next integer possible. So I go for the 2. 2 also make this one an integer, because 4 over 3, that's an integer. We shouldn't have an integer. So next one I go for the 3. So if I substitute 3 for this, 3 cancels and make this one a 2, and that's our fundamental period. Since we have an integer axis, this is a periodic and it has a fundamental period of 2. So this is also periodic. Okay, let's look at the D part of this, sine 3n. Sine 3n. Okay, again I put 3 capital N, equate this one to 25k, and if I rearrange this one in terms of n, this is 25 over 3 multiplied by k. Now if I start 1, 25 divided by 25 divided by 3, that's an integer. If I start with substitute 2, 3, even 3, I get 25. 5 is integer, like it comes like 3.1 for something like that. I mean, it's not an integer, it's a fraction, 3.1 for something like that. So for this one, we cannot have a whole number if we put any number, any integer for k, which means this is not a periodic. This is not a periodic, so we are not going to have a fundamental period. This is non-periodic, because we cannot have a whole number when we substitute any integer for k. Okay, and that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.